science stuff.
Hello and welcome back. Today we're dealing with an experiment that it will be very interesting, I think, because it basically is an explosion. Now you might see videos around the internet of an experiment that you could, I'm not saying you should, but you could do at home, of a bottle being filled with water, put in the microwave, and then when it's put into cold water again, there's like a little explosion and the water from the bowl or somewhere rushes up into the bottle and fills it up. However, unlike many other videos on YouTube that already done this experiment, we'll try to recreate the experiment using science. We'll try to dig deep into the experiment and ask ourselves, why is this happening? We'll try to explain it using diagrams. And hopefully you'll learn something new about how gases behave. Let's get into it. First, however, we'll go to a little introduction about this experiment and really try to understand how it works before we actually go and do the experiment. Because you should first do the background research before you attempt to do any experiment. So, let's get into it. I think we're all familiar with solids, liquids and gases. Solids have a tight structure which is only slightly vibrating. In liquid, the particles can slide past each other, but still they are connected, there is contact between them. In gases, each particle can be found separate from other particles, with no other particles touching it on its perimeter. However, sometimes if two particles get close together, they can bump off each other. Both water and gas are made of small particles of the medium. These particles will be represented by the blue dots. If the particles are close together and are effectively touching each other, we call them liquid. Right now, the water is in liquid form and hence forms the water at the bottom of the cup. If we add energy to the vibration of each individual particle, which increases the amplitude of the oscillation of the particle. Hence, the particle vibrates more with greater amplitude, and hence transfers more energy at every collision with other particles. This makes some particles to flow out from the liquid and change into gas. If enough energy is added in form of heat and hence the thermal energy is increased, the water will change entirely into steam. Steam is the gas form of water, and hence if we heat water, we will produce a gas, which is water vapor. In steam, the particles are not actually touching each other always, but are colliding with each other only. This means that at any point there is some space between each particle. This makes water expand as it heats up. So, the same amount of water will produce a larger volume as soon as it's turned into gas. Hence, if the water is at the bottom of the bottle only, after it is heated up, the gas will spread through the entire volume of the bottle, and hence the water vapor could be found throughout the entire bottle. Now, if we consider all the water evaporated, we see that the entire bottle is filled with steam. Now, what will happen if we cool the steam down suddenly? By putting the bottle into a cold water. Well, if we cool down steam, we take away energy from the vibrations, which means that the vibrations will be less, and hence the blue dots, which represent the particles of the medium, can now get closer to each other because they won't get kicked away by the vibrating gas molecules, but can get closer as each molecule is vibrating only less, and hence they can get a lot closer. Now we form liquid, but as we clarified before, with gases turned into liquid, the volume actually goes down, it decreases, and hence the bottle will no longer be totally filled with water vapor, but there will be only a thin layer of water at the bottom of the cup, or of the bottle. Now, if we block the neck of the bottle, we block the entry so air cannot flow in and out, basically by dipping it into water, and then while there's steam in the bottle, and if this water is cold enough, or we somehow cool the bottle down, the steam will change into liquid. However, this will mean that the volume actually decreased and there's space left. As no air can enter the bottle, this space is basically vacuum. The water from the neck of the bottle will be suddenly sucked into the bottle as the vacuum is formed, and vacuum is not a very stable thing to have, and hence the water will rush through the bottle to fill this vacuum. If this happens, we can observe something similar to an explosion, where the water gets sucked in with surprising amount of force. So, to review what happens, we heat up a bottle which has some water in it. This water changed into gas forms as its oscillation increased as energy is added by the microwaves. Hence, we increase the volume. If we block the entry by water and then cool the bottle down, if the water is cold enough, the steam will change back to liquid and hence create a vacuum, which will effectively suck in the water from the bowl and hence create a little explosion almost. Let's now proceed to the experiment. Well, this will be demonstrated practically. For this experiment, you will need a bowl that can be filled with water. You will fill this bowl with very cold water. Preferably you will also add some ice to cool the water down even more. You will also need a glass container, a glass bottle, that has a narrow opening. You will fill the bottle with some water, but only so much that if you turn it to the side, the water won't spill. You'll put the bottle in the microwave and heat the water in the bottle for approximately 3 minutes. You will start the microwave and watch the water slowly boil away. This will create steam that will be trapped in the bottle. After approximately 3 minutes, you can pull out the bottle, but be sure to use a rag or a kitchen glove or some kind of insulator because the water bottle will be really hot. Make sure that water in the bowl is really cold, and then we can try the experiment. Putting the heated bottle into the ice cold water, we can see that the steam is suddenly changed to liquid, which creates a vacuum which sucks up some water from the bowl. However, this is not the reaction we wanted. So I tried a bottle that has a narrower neck. As you can see, the reaction is quite faster, but still not what we wanted. I decided to go extreme. We have to make the water a lot colder, and so we will break some more ice. After the ice is broken, we can add it into the water. This will make the water as cold as it can possibly get with regular ice you can find at home. We also increase the temperature of the steam by increasing the time that bottle is in the microwave. And finally, we get our result. There is a mini explosion as the water gets sucked in with force into the bottle as the steam compresses and vacuum is created. The experiment was a success. The bottle actually exploded in the microwave. As you can see, it's missing the top. It's right there. When I was about to charge it the second time, the bottle actually broke in the microwave and shattered the tip of the bottle. Glass is a dangerous thing to play with, and you also always should wear safety gloves, goggles, and also preferably a lab coat. So as you could see, we managed to suck in some water into a container as the water cooled it down and the steam compressed into liquid and hence created a vacuum. We also managed to crack the bottle, and so again I remind you, if you do this experiment, wear protective gear, wear protective gloves, protective goggles, and also a lab coat as we were dealing with boiling water. Hope you learned something new. Thank you for watching and see you next time. Thank you for watching this video. I would like to acknowledge that I was inspired, and this experiment was inspired by the video I've seen done by the King of Random, who basically introduced me to the experiment and made me make a video explaining the science behind it. I'll link his channel in the description. He's quite a big YouTuber, you might have heard about him. Anyhow, also there was a lot of time and effort put into this video. It actually took me over 3 weeks to make this video with all the edits. So if you find this video interesting at all, and if you perhaps learned something new from this video, I will very much appreciate if you could like this video and show me that there are people enjoying the things that I make. Also, please subscribe to our channel if you're interested in more of these videos. Subscription will only notify you that there is a new video coming up. There's nothing else you're doing by subscribing, so I think that's pretty much worth it if you want new videos and if you want to be notified when they come up. Also, if you are interested in science stuff and in seeing science experiments, you could maybe click on this video right here. This video up here, the annotation, if you click it, it will bring you to a different video with a different science experiment. For now, thank you for watching and see you next time.